Hello everyone, good to have you here. Today we are here for our webinar on wind and seismic loads on CYPECAD. And I have here with me Diego Cuellar, our engineer from our technical department and who's going to teach us the software. Hi Diego, good to have you here.
Thank you so much. I appreciate
Okay,
that.
so yeah, we're gonna have a lot of time to speak with Diego and to learn more about the software. So, Diego, what do you have to tell us about? Today we're gonna talk especially about CYPECAD, right? And seismic
Yes.
and wind loads. Tell us a little bit about it.
Okay. Well, first, I would like to introduce myself. My name is Diego Cuellar, and I work for this company in technical support department. And today, as you know, Douglas is telling you, we are going to use the software CyPECAD. We are going to cover also seismic and wind loads, as you can see in the screen. Also, yeah, 1 second. Well, okay, the highlight for this presentation, we're going to have a brief introduction about the program, about the codes. You will see a lot of codes in this program available. Also, general settings in CyPECAD. Also, overview of the load types that can be interesting in the program. Example of setting up with wind loads and also with seismic analysis. Also, effect of the elements in the seismic analysis, examples of results with analysis of deformed structure. Okay, this is the highlight for today. I hope you are going to like it. What we are interested in is to show you in a brief, in brief, how easy it is to work with this program.
Okay, that's I think important topic for everybody.
Yeah.
Like, yeah, I think seismic and wind loads are, especially seismic loads, are very yeah, people get scared of it because it's complex calculations, complex analysis, and it's good to see that inside we can do it in a simple manner and very easy manner, right?
Yeah, you're right. Absolutely right. So, okay, allow me to close the camera because you will see a big screen for now. I'm going to close it, please.
Okay, I'm gonna close my camera too, so we can actually watch the presentation.
Thank you. Thank you, guys. Okay, so today I'm going straight to open the software. So we have CyPECAD. Our building is going to be something like that. Also, we have two options here, the 3D view of the building. And if this project are coming, the model is coming from the project called software called architecture, should be something here, okay? So both
Diego,
options.
one thing that I think we can remark here that I've seen in our previous presentation is that when we see anything that is presented, let's say in the 2D model in red, that means that's something that needs adjustment, right, to comply with the regulations. In that case, we're gonna see how we can adjust and make those columns that look in red look green, so that we know they are ready, right?
Yeah, right. You're right. Okay, guys. I'm going to disable the floors, then the beams, and then the columns, just to show you that these elements in this software, we can do it in two ways, as a concrete walls and also as a shear walls. Later, I will show you another example that we can see more details about this particular option. We call it here interoperability between software. For instance, we can start doing the model in architecture software. Then we can export that to our cloud, our BIM environment, and then from that part we can export to AutoCAD.
So
Yeah,
when
I'm
you
sorry.
say architecture, you mean Cype architecture, right? And we can,
Yeah,
yeah,
Cype,
we can
yeah.
work in a BIM open BIM workflow where you can connect then to CyPECAD and keep working. And in this case, even with our software for shear walls, etc., right?
Yes. From here in CyCAD, also we define this structure as a shear wall. We are going to use the effort to export again back to the BIM environment and we are going to use another software called OpenBeam Shear Walls. From that software, we are going to see or to get the reinforcement, and then we can use another software to get detailings about drawings and so on and so on. Okay, that's the process more or less, the proceeding. So I want to show you here how tall is this building. In this site, we can edit the floor. We have here around 80.5 meters height, and also another question that regular people ask is what really means this bracket. Bracket means that the three floors are working together. If you make any change in one of them, are going to affect the rest of them. So okay, so we can continue with this stack beam definition. I'm going straight to the subject that we are going to cover today, about the general data. So the first thing is to visualize about the codes. Codes implemented in the software in concrete is all
I
of
think
the.
that's a very important topic for everybody, right? The amount of codes that we have in CYPECAD is very interesting because we have many, many options for people to select.
Of course. We have, first of all, the Spanish code, then the Euro codes, then Singapore, South Africa, France, Italy, United Kingdom, Russia, America, from South America, Brazil, Argentina, Chile, Bolivia, India, you name it, okay?
It's interesting that I see that you have Chile there because I think it's one of the most affected countries by seismic loads, as far as I know.
Yes, that's one of the most active countries in South America, following by the Colombian and Mexico. About the code for steel, something similar, the Spanish ones, code, the Euro codes, the Singapore, Italy, Kingdom, Germany, America, Mexico, Canada, South Africa, Austria, New Zealand.
And I
Also,
see that you have many, many codes for this is for the types of materials, but we also have the codes for the actions, right?
oh yes, of course. I will tell you later how to do it. For roller steel, we have the same thing, Spanish one, Euro codes, and so on, so on, South Africa, etc. And for the timber, we are using a few of them, but I'm choosing just the American one. And for aluminum, we are going to use Euro code number 9. For roller steel, for roller block walls, Mexico, and composite slab, Euro code number 4. Okay. And another thing is we can check in our website something similar, but about the codes. You can search here and narrow your research by country. For example, you can select here, for example, America. You can go to United States. The category could be, for example, structures, and then could be concrete structures, and then all you can see you have a complete report about the code that we're implementing right now.
It's great to see that we can go to Cype website and clearly find the regulations that we have implemented in the software. I think it's a great option for everybody who is willing to find out if Cype actually complies with what they need. It's a great option.
Yeah. So we continue. Well, actually, we have here 4 sectors. The first sector, second sector, third sector, and fourth sector. We are going to work more or less in this sector, okay? We're going to focus on this part of the software.
Okay.
So
So
now,
here we're talking, we've seen the codes for materials, and here we can see clearly the codes for the different types of actions, right? And forces that affect the building.
Exactly. So we have this button. It's a quick way to check the dead load and light load. If you have any remarks about the foundation element that we are not covering here, you just make sure that everything is on place. And the second button which is the wind loads conditions.
So
Okay.
just to remark to everybody, we've started with the actions part, the loads, and this is wind loads. We're seeing only wind loads.
Yeah, by default, I was chosen America, but one regular question is, what happens if I don't have my country here? Can I use the software?
That's interesting.
Yeah, yes, of course. So you can choose general method, and from here you must introduce these kind of coefficients, information that you might have. In this case,
And I believe you can even bring information from an Excel file if you have the information about the wind loads in your country, right?
oh yes, absolutely right. Look, if you want to have, for example, a new code, no, sorry, a new reference, the pressure curve, you can be here. You can introduce as much detailed information that you want, and then you have the new spectrum here. But this curve, you can store it and you can share with your colleagues because you have to do it just once. You can start from Excel software and bring it here automatically. The rest, is just straightforward. And we continue. Well, I have something that I want to show you is about well, I'm going to continue with the American ones.
Okay.
And so with the American, we have the ASC 716 and 710 and 705. So the latest is the 716. Allow me to skip this because I want to show you something important about the directions. I have this picture who allowed me to explain why we have
Visualize the loads, yeah.
why we have X and Y, positive and negative. And that means that when we are taking this force, suppose that we have that load here, the wind load affect the warehouse, the wall of this warehouse. So that force, we divided that force in two forces. One positive, another negative, with eccentricity of 5%. Okay, that's why we have this. Another thing is these locations, you want to call locations, this is something extra. Anytime you have some books on open books, on one of the icons that you will see it is regarding to more information about the topic. About the tributary width is the size of the building. The building is rectangular, 20 by 20. One of the things that we're looking for when we are doing the modeling, also the designs, is to get the magic word here is symmetry. So also we have by floor here. So we give some, you see this, for example, on the roof, we have some, a small part, maybe the leaf is a little bit longer because we want to repair on top. We almost create that things. Over here, and at the bottom, give you the description where it's located, how it's located the building. And then the location data. Here, the location data for this code, we have something like that, the wind map location. And I would like to go on with
I think
another
it's very
countries.
interesting, right? Because people can visualize the wind loads that you have throughout the country, and we can see clearly that the codes are implemented here. We can see each part of the country, how it is.
Of course. So let me show you one that I like the most is the Russian one. The Russian. We have something like that. So beautiful. It's different. It's a very large country, For people who are located in Poland, for example. In Poland, we got that too. And what else? You can continue. It's a lot of information in this software. So we continue with the American one. Then we have to decide the terrain category. We're going to keep it single. And also look by directions. Remember, 0 direction is like this, 120, 180, 217, and 90.
Yeah,
Different location
I
given.
remember.
90, 117 means the front of the building. Okay, just as a reference. So we continue with this description about the category of that terrain, and the land orography also could be flat, and also the building can be located on top of the mountains, and also something more specific about exactly the locations, and so on and so on. And also we have something here which is the secondary effect, ordinary effect. Yeah, Douglas, you were saying something?
No, it's not. And yeah, that's something that I wanted to ask you about the effects of second order. I think that's interesting that you go ahead with it.
Yeah, good. So imagine that you are having the wind action are going to affect the building in different ways, and the building are going to have some displacements. If those displacements are going to affect drastically the internal effort of the building, we have to find a method who are going to analyze the building differently. That means that we need to go into the elastic nonlinear analysis. So it's because the structure itself are going to have some deformation, especially columns, and also perhaps we are going to have some cracks. So we have a simple method called the P delta effect. We are going to run in the linear analysis, first degree linear analysis. So what happens is with this method, we are using an amplification coefficients to every horizontal hypothesis, horizontal action in the building, and we with this amplification we correct, we verified if those conditions are okay or not. We have as one value. We know that the top value is going to be 1.5. If all those values are less than 1.5, our building is okay. Let me show you a little bit more. So that coefficients has to be, the gamma zeta coefficients have to be less than 1.5. And we can travel, we have around 48 combinations. The actions are going to be the set weight, the dead load, light loads, wind, and earthquake. So we must go all the way, to see if this is okay or not. In this particular case, everything is fine, okay? So we can assume that everything is okay, that then we are going to run the analysis. And on the bottom, we have a report that you can consult, but also we have the same report when in our list. So you can, check it out, see on the way.
Clearly see the full information here. Yeah.
Yeah, it's completely important to know that this part is the coefficients, one of the coefficients that we have to measure.
So this is the second time you show us a report that we can clearly see the analysis that's being performed and the information that it's using. I think that's something very interesting in Cype, because all the reports, they include the actual equations utilized and where they took information from, so people can actually verify the information, right? And there's no black box here, and you can actually see how it's doing the analysis, and you can even, if you want to question it yourself, you can actually see, okay, do I know this equation? Do I agree with this equation? Because we are very proud of the analysis that we do in our software.
Yes, absolutely right. Okay, so this coefficient, this value, it goes between 1 and 2. But you, as an engineer, you have to, with your well-known, you have to define this coefficient. You have to take in consideration the rigidity of the software, ductility, and some other aspect of the building. It's open for you guys to do it. And okay, so I think we covered that part. About the seismic load, I prepare already very nice slides. Let me extend this. It's called, I'm going to help myself with this slide to explain you how the system works. Okay, so you know once the earthquake happens, creates a weight, no? So that weight are going to be from one place to another one, but we are detecting that weight from tools like accelegrams. From those accelegrams, we have the frequency, we have the the acceleration, also mainly those kind of facts we are going to register here. But the weight are going to travel also all the way. So we need another thing, which is this part of the type soil. It's not the same if we are going to have rock or a mix of soils, something like that. What happens is that that weight, even with these accelegrams, we can detect the source of that weight. So with the weight are going to travel from the bottom to the top to the surface. When they reach the surface, the weight are going to reach the building, and they're going to travel all the way to the top. And then the building are going to move in this direction. By the way, we are taking in account that we are covering X direction and Y directions. There are some things that we can apply 100% in one direction and 30% in the other directions. That means that the amplifications, the simultaneity of the maximum vertical and horizontal seismic response is unlikely. It means that it's impossible that the seismic weight are going to happen both ways at the same time. That's why we are taking 100% in one direction and 30% in the other one. In the software, I'm going to show you later how to set up that part. Okay, so then we come up with different formulas. The famous formula, force is equal to mass by acceleration. And then we come up with another very more complex formula because we want to to understand the behavior of the structure. And we have very complex formula like the matrix mass, also the stiffness mass of this building. But these formulations are very complex, and we are using now computers who makes our lives more easier. So with these tools, we can do the job in a very short time. So then we go back to the spectrum, design spectrum that we are having here, the periods, the accelerations, and also we are considering the type of soil that we are having here. This is part of the information that we are getting, and then we have to find the vibration of the structure. In this case, in this case, we can use the dynamic and static analysis, and also we can considering the rigid diaphragm. I forgot to tell you that. And also we are saying that the software is we assume the first degree elastic linear analysis, and also the software we can use the accelerogram to get the frequency, the period, and the acceleration. One thing that I almost forgot is that also we have the acceleration of vibration mode of the software in 3 ways. One we can choose the code. The second one are going to choose the percentage of matter we're going to excitate in the software, in the building, sorry. And it goes from 90% to 100%. And the last is something that we call by user, which are by default we have a number of 6, but we are considering only 3, X, Y, and 1 rotation. And then, using the model expansion combinations, we can, using the CQC, the method CQC, we obtain the particular coefficients for different analysis directions, which are the linear response. So by the displacements, we have to correct those displacements according to the code. So that drift is possible because we have in the list a bunch of information regarding to that part. So you can check those reports and verify if you are according to the code. And finally, the effort or potential, whatever you want to call, we are using those effort from CYPECAD. You remember that we are trying to in this particular job in our building, we have the concrete walls. So that concrete wall, the effort that concrete wall, I exported to the software OpenBIMserver Word, and then from that part we are going to the software called OpenBIM Rebar. Okay, that's it for this part.
Okay, interesting explanation. So we were seeing everything regarding to wind loads, right? I believe now we're going to move towards seismic loads.
Yeah. It's very hard to understand that physical, this interaction between the earthquake and the weight, how it happened. Now the formulations are the consideration that we are going to have in place. It's so difficult to understand that part.
Of course, it's a complex topic.
Excellent. Look, when I think the American code is the most complete because on this side we have the uniform building code, and if we chose that, we have the international building code as well. That means that you can use it any part of the world using this code. Also, we have
That's great.
Yeah, the international building code from IBC, the ISCE 705, 710, and 716.
But I see that we have many international codes here. In 2015, as I said before, I know that Chile is a difficult case, and I was living in Chile, and I was through 8.3 earthquake, and I was living on the 20th floor, and nothing happened to the building because the buildings there are very well built. Maybe you can just show off some of the codes that we have here to show people that we do have different types of scenarios.
Chile, for example, this is one of the nicest. As you mentioned, it's very, very hard, to.
And we have many countries, and also, as you showed before, the general method for people to implement the codes that they have on their own country if it's not available here, right?
Yes, it's available here. Thank you for reminding me. A general method. Also, something similar like before. You can display here. We have some examples around the world. You can use it. It says something similar is possible. Sometimes I know people who can take advantage of that part of the software because it's available. The same here. Yeah. If you have that spectrum.
And as we said before, you can even import information from an Excel file or whatever.
Yeah, that's what I'm trying to tell you. And also you can create more libraries. You can share that with your colleagues. You can export it, load it, and come back. And
great.
Well, it's a very nice part. Okay, so we go back, to the American code.
Okay.
American code.
Yeah, there we have it.
Yeah. Okay. So I was telling you that we can do both the dynamic and the static analysis. I recommend you to use the dynamic or modal spectrum analysis, which is pretty cool. About the spectrum definitions, we can do it using the general method, or you can use it in this part specific by the user. Suppose in the macro zones, you have some, in that, that map that I told you, I can show you later. That map, maybe over here. No, here, not in this normative. Let me choose another one that I know better. For example, here, for example, here, the rest of the territory, we can go look. These microzones is very hard to detect. Suppose you have the building that you are going to design are in between these two lines, so in the border. So for that purpose, could be, I can use, for example, the specific by the user. I can make some numbers. I can, extrapolate these values and create a new spectrum. That's another way to use this part of the software. About the spectrum definitions, I'm going to use by the code. About the analysis parameters, depends on the building. Sometimes you have a warehouse and you are having a kind of mezzanine, we call it the second floor of this store. You can use it as a store place. Maybe you have offices or something like that. You want to consider part of that load here, the live load. So just write it down. And the same thing for the friction snow load, if you have it. And about the structural system, they go by codes. Clicking here, you must define the type of structure and an X and Y, and definition, application, amplification factor, same thing by the code. Type the structure, and then the acceleration parameters, same thing, you go by the code. And the soil type, you must define this, depending on the area, you must have some information, extra information regarding to the soil that you are going to deal. From then you have the acceleration. About the rig category, it's possible also by the code. There's different sectors depending on the importance of the building. Perhaps you are going to do a hospital, clinic, government building, and so on and so on. So that kind of importance is important, to classify the building, the category of the building. The estimation of the fundamental period of the structure by the code as well. You have 4 sections. And the number of variation mode, as I was telling you before, you can use the code, or you can use automatically define the percentage mass that you are going to excitate, and also by the user. By the user, we have 6 here, but we are covering by floor, we're covering X, Y, and rotation. So I'm going to choose this. Effect of vertical seismic components could be done by the code, and also if we choose the second one, they specify by modification coefficients. These coefficients are taking 2/3 of the vertical or the horizontal acceleration. Same thing for the base share condition verifications, which are, if you suppose we have a basement, maybe 2 or 3 or 4 basements, and we want to have it in the solution, the final solution. This particular building is on the surface, but if we have an underground, we have 2 or 3 or 4 basement. If we want to include the part in the building to verify the share on the basement, it's possible to do it or to include it or not. Same thing, we have an extra graphic according to the parameters that we are chosen about the design spectrum. And beside that, we have the same thing for the secondary effect with the P delta method. So I think this is it for this part.
Okay. So we've seen now the seismic loads, right? We've seen first the wind loads. Now we've closed the seismic loads. I think there's something here that I'd like to maybe show to people, is that we have there the building elements. That's something that we can add to the seismic loads to analysis, which is something that Cype has developed in collaboration with the University of Catalonia. And I think that's something unique. You won't find it in anywhere else in any other software, because that's something that we developed ourselves in investigation with the university. And that includes all the other elements that contribute to the rigidity of the building, like the facade, etc. Right?
Yeah, right. I forgot to mention that over here we have a description about the by floor, about all the wind loads is automatically. The program do that automatically. And the report,
oh yeah, I can see, yeah.
The report is like that. You can export that to any format, Word format, can
Yeah, it's great to
close it.
see that. Yeah.
I
But
forgot
just
to
to
tell
show a little bit,
you.
what I mentioned about the building elements, which
Oh, yes,
is
sure.
there, like in the seismic loads, that I believe is something unique from Cype. Maybe you could show a little bit.
Yeah, sure. I forgot to tell you that the utility factor has to be here. It's so important to choose that part. And then, as you know, Douglas are mentioned, we are considering something really, really nice here. We are part of the, well, before that, well, we are, Cype belong or are part of, the working with different universities doing some research. And they were getting also some funds or money from different sources. Could be the European Union, could be these departments, the CDTI, I don't know the acronym, which really means or stand for, but the other ones, the CIMNI, this is the International Center for Numerical Methods in Engineering, CIMNI, and in collaboration with the Cype, they develop this part of the software, which is unique, as Douglas say. None of the software right now in the market can do that. So I'm allow you, I'm encourage you to use it and take advantage of this, because we can combine these solutions with another part of the software, which is the soil interactions. And with both, I will tell you later what we can do with this. It's so cool.
Okay, great.
So finally, the fire resistance check. And for this, remember the problem. Remember what happened on the September 11th? The twin towers
Yeah,
collapsed vertically,
yeah.
like a house of cards. So this is due to the high temperature to which the metal structure was subjected. And we have this option here. We have to define the time that you are going to expose or to check. Maybe in Spain, for example, by regulations, all the warehouses you have to measure by 2 hours. You can use different materials. You can use foam. You can use any other, for example, fire retardants in the structure to cover the structure, just to make, to save life, in general, to save life. But we have that option here in the program.
Great.
And
So just to make a quick review for everybody, we've seen now all the codes that we have for materials. Then we went to the loads, which is what we are focusing today, which is the part where we saw the wind loads, then the seismic loads. Now we've just showed the fire resistance, and this is all in the general data of the CYPECAD software.
yes, Douglas, remind me something. When you use SAP 2000, another software, anything, it's very difficult, to to get into all in details about all these selections, all these
Oh, it's
parameters.
a very complex matter, and I know that many people are still working with Excel files and etc. And anybody who's working with that knows that this is a very, I don't know, extenuating analysis. It takes a long time. It's very complex. And here you can add all the elements. You've shown us that we have the codes. We have so many variables that they can add to the analysis to their own particular case, and then it's quite straightforward, right, to do it in Cype.
Exactly. This software is all what you need for, and it's a very in this the way they are doing it, especially these horizontal forces, is so straightforward. So you don't have any doubts, following the step by step, the end of the process. So Douglas, you were mentioning about the limb state combination, right?
Yes.
Okay, I'm going to cover this. We have here, but for concrete, we have the combinations here. All that is a summary about this. And also, remember the X and Y coefficients that we're going to have when we are implementing for example, the seismic load. So we have to come here, click in it. You have, a copy of those that we already selected, but going into the seismic loading on the bottom, you have to write here 0.3, which is the percentage that we are considering. We must go, for example, in the Y direction, 100%, in the X direction, 30%, and vice versa. So if you don't do that, you are not setting the program the right way. Also over here about the additional cases. So we have by default to describe the category of the building. Also, we must note that the set load and dead load are automatically in the software, but even so, you can include a little more. And in this building, we have one live load here, and also we have 8 categories automatically, wind load categories, and the earthquake 2, X and Y, and so on and so on. So one thing that I want to remind you that you can include as much as one, especially the additional ones, but it's going to take more time. So try to make it simple. Okay, simplicity I think is the right word here. So accept it and accept. I think this is it for this part. Now we're going to see the results.
Yeah, I was going to suggest that we've seen all the general data. We took our time to show all the data we can add to the project. Maybe we can show the types of results that we get and the reports that we get from this software.
Yeah, before going into that, I'm going to show the deformation shape. Just quickly, briefly. Okay.
Okay.
Mm-hmm. So I'm going to maybe upgrade 500.
Yeah, that's a great part of the software because it's very visual, right? For us to notice, and here you're putting like an exaggerated load, but yeah, we can clearly see how the load affects the building, right? It's very visual.
Yeah. I'll show you this. So this is the rotational mode. You see? Okay, so
yeah, we can clearly see the whole movement. Yeah.
I know already that the mode treat in the X direction is the most important one, but I'm gonna show you this information in our papers work, in our list. So we're going back. So I'm going to show you, first of all, the wind action justification. So velocity per pressure, the design pressure, the wind load per floor. If we go down, we have all these, the velocity, the wind velocity speed, direction, orography, the tributary wind, and also tables showing you by floor.
Once again, we can see all the tables with information, floor by floor. We can see all the equations used, and that's very helpful.
Yeah, same thing. You can export that to PDF format, Word format, and so on. And about the justification of seismic actions, which is really important, earthquake data, design spectrum, participation coefficient, the center of mass and stiffness, correction due to the base shear by the method CQC, and the combined seismic shear per floor. Rolling down, we have this location characterization, using that formula, that code. These are coefficient, the response modification coefficient, which are so important to have it. The total height of the building, light load percentage, the design spectrum by this formula. And continue. The reduction coefficients to get this design spectrum in X and Y. Now, this is the most important table here. So we have the modes on this side, in this column. Remember that we chose the automatic way, and we decided to take in consideration 90%. So the software goes up to the mode 13 and reach 94 and 94. That means we are okay. So the other factor, the other coefficient, this is the period, and also Lx, Ly are some coefficients, participation coefficient to the rotational degree of freedom, and R are going to be the rational of the accelerations. A are going to be the calculation of acceleration, including velocity, and D, the mode coefficients. So once we want to know about how the building is moving, I know that the first mode we get the highest period from this data, and also traveling here in mode 3, we have almost 40% of the mass in the X direction moving. And also another data which is important is to get to mode 2 is around the, I'm sorry, this over here, mode 3, the rotation, this is the rotation of the building, goes close to 1. That means it's the strongest one. So in mode 3, as you saw before, is the rotational period. And yes, if you travel, you can get more information, but in general, this is the most important aspect to cover. That is an spectrum according to X and Y. The building is around here. Now the landscape seismic in X and Y. In the center of mass and center of stiffness and eccentricity of each floor. The graphic representation about the center of mass and center of stiffness. We do now the dynamic chart CQC method. This is the total one. In this, the dynamic, and the total dynamic in Y. The static shear, base shear. This is the total weight of the building. Over here, total weight of the building. And now the base shear condition verification. The red one means that the software internally do some calculations, and if we need this coefficient, the software are going to affect automatically, to amplify it automatically. And quick conditions. This is a graphic about the table before. The same information, but graphically. And that's all, And another thing that sometimes I forgot to tell you is about this job data report. It's it's our choice, that we did that part, but you can display the way you are going to present this information to any entity. Could be the government or private entity, but also you can customize those reports. Like here, for example, you can click here and start, choosing from here to that, and you start getting, just doing something else. But that's the way. And then step by step, you are going to present that paper to any entity. Okay. Okay, guys. So I'm going to change to another example that I already prepared for you guys. Is this one?
Okay, might illustrate us better, right?
Yeah, sure. Because these buildings, tall buildings, always has a core, and this core is located sometime like this. The these blue beams, the blue beams means that we are having connecting beams. In the software, open beam shear walls, you can define, you can get you can get the reinforcement in this, because this reinforcement is different than the regular one. This diagonal reinforcement is the way to do it. And also there are something like here in this corner, and maybe this corner. You have different options here because the reinforcement in that area is completely different. We call it the edge reinforcement, and it's possible with that software to get in detailed the amount of reinforcement that I'm going to have in that areas.
Okay, Diego, I've just noticed that we might run out of time, so we are going here in deep detail. I think it's great for us to see. We have some more reports to see right before we close our presentation, because we reached the end of the webinar. I think that's something that would be important for people to see, right?
Like what, Douglas?
Some of the reports. Is there anything pending, or have we finished anything? Everything?
No, we finished. We finished.
Okay, so I think we could remark something that everybody would be interested to know, is that this software is part of a big workflow, right? With different Cype softwares, and maybe I can share my camera again so I can maybe talk to people. So CYPECAD is part of a family of softwares, right? They are all working together. They connect in our BIMserver.center, and maybe we can visualize this more here. For example, Diego has like the core of the building has been done with shear walls, right? Or the first case that you did.
No,
Yes,
this is
and
something.
you can generate this with one of our softwares and then move to the other, and you can do this seismic and wind analysis on CYPECAD in the end with all the options that we showed here, but it's connected. Let's say you can work in Cype 3D and create a metal structure and connect to that building. You can create shear wall structure and connect to the CYPECAD model, etc. Right?
Yeah. This example is pretty cool. This is well, it's an hotel. It's more than 200 meters high. Look how big is this software, and also
Yeah, that's a great project. You can
it's
clearly
a
see
very nice
all the
project.
capabilities of the software. It's an actual real project, right? That has been developed.
Yeah. Yeah.
It's a great example. Great example.
Yeah. So
So I
thank
think
you.
we managed to show a little bit of what the software is capable of and how we can, like, in very precise detail, determine both the wind and seismic loads and analyze it. Something that looks complex and that in CYPECAD can be done very simply. But also we've seen like the all the options we have to really determine it as you have it in your local market, in your specific situation, right?
Right. I think this is it,
I think,
Douglas.
yeah, I think that was very instructive to everybody. During our webinar, we've been collecting questions. I know that people have lots of questions here because it's a complex topic. It's a very technical topic, and our colleagues have been answering the questions, and we are gonna send messages to you answering any questions you have according to any specific topic you want. Remember that right now in November we have the Black Friday, and we have some very special prices, and I hope you guys have enjoyed our webinar and that you have learned something and that you test the software. Please go to the BIMserver.center or to Cype.com, download the software. You have 10 non-consecutive days, that 10 working days, which means that if you use it on Monday and don't use it on Thursday and Tuesday, you test it again on Wednesday, that's only 2 days. So you can use 10 working days or 10 non-consecutive days of the software for free for you to test it and see if it applies to your case. And I'm sure you're gonna like it. So Diego, once again, thank you for your time. Thank you for showing us the software and all the very many details that you showed us. And well, I hope to meet you here for the next webinar.
No, thank you, Douglas, for helping me to show this program in a very easy way. Also, with your interaction in the webinar, and thanks to you guys who are watching us. It's enjoyable, and pleasant to show how easy it is to work with this software. Also, I'm encouraging you to go in our platform. It's so easy. All you need to be part of this BIM environment is just to your I don't know, information like can you help me, Douglas? I forgot that.
Yeah, but we get the idea. I think. Yeah, you're a great ambassador for our brand because you've tested it for so many years, and I think it's great for people to see. So everybody, thank you so much. Have a nice day.
You too.
And I hope to see you in the next webinar.
See you then. Bye-bye.